let me start this example. I'll probably have to reference this stuff in a second, but let me just start it. So when I look at this question is asking me to find the area under a curve. So the first thing I should do is I should identify what my curve is. And I hope we can all see that my curve f of x is equal to x squared minus 2x. Does that make sense to everybody? I also want to identify what my a is going to be, and the a should be the lower limit of integration. So that's going to be 1. And my b should be the upper limit of integration. So in this case, it's 3. Okay. So what I want to do is I want to approximate the area with rectangles, but then I'm going to take the limit as the number of rectangles goes to infinity. So the width of my rectangle is always going to be delta x, and that's equal to b minus a, put that in parentheses, over n. A lot of my other examples started at 0, so life was easy. This one is a little bit more complicated. This one starts at 3. So this is 3 minus 1 over n, which is 2 over n. Is there any questions about that? Because we really need to, I guess, find delta x always. Okay. So up here, maybe I should have told you earlier. I mean, I said this when we did the 4.1 section, but this was b minus a over n. Okay. Now, for us, we're going to focus on the right endpoint. So if you look at this picture here, in general, this is the picture of my region of integration, which goes from a to b. And I chop it up into n pieces. And then I want to grab a hold of some generic subinterval. So that's what this part is right here. And when I look at the xi, this is the right endpoint. So this xi is really the right endpoint. So how do I find a formula for this right endpoint? Well, you're going to start at your first endpoint. If I looked at this first subinterval here, what would the right endpoint be? The right endpoint would be x1, right? So if you wanted to get this, you would start with your a, and then you would only add 1 delta x, right? So if I wanted x1, I would just add 1 delta x here. If I wanted x2, how would I get x2? I'd have to add 2 delta x's. If I wanted x3, how would I do that? I have to add 3 delta x's. So if I wanted xi, that would mean that I need to add I delta x's. So that's how we get the right endpoint. If you wanted the left endpoint, so let's say this is the first rectangle right here. If I want the left endpoint, I just stick with a, right? And I don't do anything else. If I wanted the left endpoint of the second interval, I would start at a, but I would just add 1. I wouldn't add 2. I would add 1 delta x. So in general, if you wanted the left endpoint for the ith subinterval, you're not going to go a full n. You're not going to go a full I delta x's. You're going to go 1 less to grab the left endpoint here. So this is going to be a plus I minus 1 delta x like this. And this is the left endpoint, while this guy is the right endpoint. So when we do the 4.2 questions, we're really going to focus on the right endpoint because that's easier to work with. So we'll use this right endpoint over here. Is there any questions for me so far? All right, cool. So we are trying to construct our Riemann sum, and we're going to go from 1 to n. We got f of xi star times delta x, right? And then we know what our f is. So this is going to be the summation as I goes from 1 to n. This would be xi star minus squared minus 2 times xi star, all this times delta x. So what did I do? I just substituted in the xi star into my function f right here. Is there any questions about that? Okay, great. Now, based on what we had just said earlier, xi star, if we use the right endpoint, maybe I should mention we're using the right endpoint somewhere. I'll do that in 1 second. That's going to be equal to a plus I times delta x, right? So for us, that's going to be equal to, the a value is 1, and my delta x was 2 over n. So this would be 2 over n times I. And this is because we are using the right endpoint. Does that make sense to you all? I put the I in the back instead of in the front of that term. I generally like to have my variables in the back and the constants in front. And I don't know. Does anyone want to ask me anything?
Professor, I had a question.
Yeah.
How did we know to end up using the right endpoint instead of the left?
You can, that's a good question. Rocky, you can choose which one to use, but I don't really like messing around with the I minus 1 because I have to do all this distribution and stuff. So I always use the right endpoint.
Oh, okay. Sounds good. Thank you.
You're welcome. Now, I think I tried to show you guys something the other day where when you have a number of rectangles become really big, the left endpoint and the right endpoint become almost indistinguishable, at least the y values. So you can choose which one to use. So we just choose the easier one. So I'm going to make that substitution. So this guy is going to be So this problem kind of takes a lot of space. So let me scoot over here. This is going to be equal to the sum as I goes from 1 to n. We're going to put 1 plus 2I over n squared minus 2 times 1 plus 2I over n, all of this times your delta x, which was 2 over n. So all I did there was I just substituted my xi star into the previous equation here. Oh, and give me 1 second. Let me just. Okay, so we just made a substitution. Now, I wanted to remind you of something. So I want to be mindful that you're copying stuff down and give you some time to copy it, but I wanted to show you something on the previous worksheet. So last class, before we took our quiz, we did a problem like this, where you had to multiply everything out and then write everything in terms of I squared I in the constant term. And then in this case, we evaluated at n equal to 10. So we're going to do the same exact thing that we did in class before, but we're not going to put in a 10. We're just going to leave these with n's here. Okay. So that's what we're going to do next. So I've got to expand all this stuff out. So So let me do that. Okay. So this guy is going to become the summation as I goes from 1 to n. I need to multiply all those things out in the square bracket. So let's see how this goes. This might be kind of long. I won't try to squeeze it in on that line here. Let's move it here. Sorry. I might have to rearrange stuff. I'm worried about running out of space. So maybe I'll just remind you of these formulas I'm always using. I'm always using a plus b squared is equal to a squared plus 2ab plus b squared, like that. So in this particular case, this is going to be 1 squared, which is 1, plus 2 times the product of the two terms. That's going to be really 4i over n, because 2 times 2i over n is 4i over n. And then the last term there is going to be 4i squared over n squared. And that's that first piece. Does anybody have any questions about that? And then the next piece is going to be minus 2 minus 4i over n. Okay. And then we're going to close off that square bracket, and we still have a 2n outside like this. Is there any questions about that? All right. So I see something kind of cool happening here, actually. I see that actually I had this 4i over n and this minus 4i over n. Those guys kind of cancel each other out. So that's really good. And then what I want to do next is I want to distribute this 2n in. So I'm going to distribute this guy here, here, and here. So on my next line, I'm going to get the summation as I goes from 1 to n. We're going to have 2 over n plus 8i squared over n squared. Oh, wait, over n to the third power. And then we're going to have I just realized that I could have simplified the 1 and the minus 2 to give me a negative 1. It's okay. I'll worry about it on the next line. When I distribute this guy, this becomes minus 4 over n. So I noticed at this point that these two guys can be simplified. So this guy is going to become I goes from 1 to n. This is really 8i squared over n cubed. And then this is minus 2 over n. Is there any questions so far? All right. So now I'm going to use those properties of the sigma notation to break this thing down into pieces. So when you look at this sigma notation right here, your variable is I. I is the indexing variable. And really n is treated as a constant. In other words, the n isn't treated as a variable until I take my limit. Remember, out front, we're going to have that limit as n goes to infinity. So basically, when I look at this first term right here, 8 over n cubed is a constant. So I can factor that out. So I'm going to have an 8 over n cubed, and then we're going to have a summation as I goes from 1 to n. And then you're going to have an I squared here. Does that make sense so far? Now for the second term, we're going to have a minus. We're also going to have a sigma summation over here. But again, to reiterate, my variable for the sigma is I. Really, n is treated as a constant because we're going to take the limit when we're done here. So this whole term is just a constant. So I can really might write this as factor out of 2n. And when you factor that out, you just have a 1 left over. And this is as I goes from 1 to n. Okay. Is there any questions now? So this object right here, this whole line, this is our Riemann sum. Okay. Any questions?
I had a quick question, Professor.
Yes, Rocky, go for it.
For the 2 over n and the summation of 1 to, is it n and 1? Would it have been wrong if we took out 1 over n and left the 2 in?
No, that would not be wrong.
Okay, thank you.
You'd get the same answer too when we take the limit.
Thank you.
Great. So let me go back and remind you of our strategy. Our strategy was we're first going to work with the Riemann sum. That's how we started. Our ultimate goal is to split it up so that it's something, a sum of I cubed, sum of I squared, sum of i's, and sum of 1. And then we have these formulas that I'm going to provide for you on your exam. Well, I was going to provide these 3 for you on your quiz, sorry, not your exam. And we're right there. Like this is at the step where we're at. So we're going to substitute now. I just wanted to remind you of the plan. Okay. Once we do that, we're just going to take the limit as n goes to infinity. So now we're going to do it. So this is going to be equal to 8 over n cubed. That part is going to be n times n plus 1 times 2n plus 1 over 6. And then we're going to have minus 2 over n. And if you add 1 to itself n times, you just get n like this. So this is our sum, Riemann sum. And I can do a little bit of simplifying, right? Because if I have 1 n here, then I could cancel out n squared there. This n and this n cancel each other out. So in the end, my Riemann sum looks like this. It's, oh, I can do a little bit more, right? I could make that a 3 and make that a 4. Because each of those terms are divisible by 2. So in the end, I'm going to get 4 over 3 n plus 1. Sorry, n plus 1 times 2n plus 1, all divided by n squared for the first term. And for the second term, I'm going to get minus 3. Minus 2. So this is also our Riemann sum just simplified. Okay. The next thing we're going to do, so now we've found out what our Riemann sum is. That was sort of this, starting from here, we were finding our Riemann sum. Okay. And then the next thing we're going to do is we're going to take the limit. So now we take the limit as n goes to infinity. Okay. So that looks like this. Take the limit as n goes to infinity. I'm going to have a 4 over 3. Let me multiply out the top. Top is going to be 2n squared plus the outside is n, the inside is 2n, n plus 2n is 3n. And then you multiply the last two terms together, you get 1. So this looks something like this. Okay. I think what I needed to do was I can write it like this. I can write this as the limit as n goes to infinity. I can split it up into two limits. So the first limit is going to be 4/3 times 2n squared over n squared plus 3n over n squared plus 1 over n squared. But then the second piece is going to be minus the limit as n goes to infinity of 2. So when we look at this, what happens is the n squared and the n squared cancel out here. 1n here cancels out with one of those. So we're going to end up with 4/3 times the limit as n goes to infinity. We're going to have 2 plus 3 over n plus 1 over n squared minus this whole thing minus 2. So this part goes to 0. This part goes to 0. But I can't do the 2 minus 2. I have to multiply by 4/3 first. So that was the error that I made. So this is equal to 8/3 minus 2, which is equal to 8/3 minus 6/3, which is equal to 2/3 units squared. That's our correct answer.